Section 2, we are focusing on the conic section of a parabola. Now, we've learned about parabolas before, but in Section 2, we're going to learn about them a little differently. So right now, if I ask you what a parabola is, you're probably like, oh, it's a U shape. Okay, well, what exactly does that mean? Well, if I draw a little graph here, I'm going to draw out that U shape, that classic parabola that we think of. And if you think of the parabolas that we learned about first semester, they were in the form of y equals some number times x squared most of the time. Or sometimes we had a couple other things at the end here if our equation was in standard form. But our classic parent function, y equals some number times x squared. Okay, well, here's the definition, the actual definition of a parabola. A parabola, by definition, is all points that are equidistant from a specific point called the focus and a specific line, and that specific line is called the directrix. So adding to my diagram here, here's my, my classic parabola. Based on the equation of the parabola, we can find the location of this specific point, our focus, and that specific line, the directrix. So this is supposed to be horizontal. But any point on this parabola is the same distance away. And that's what I have up on my computer here. I'll show you a little animation. There we go. That I have. So here's this parabola. Okay. This purple point up at the top is the focus. And this green line at the bottom is the directrix. Now, any point on this parabola, if you look at the yellow point here, this yellow point is the same distance to the focus as it is to the directrix. The length of this little segment and this little segment is the same. And that's the same everywhere you go on this parabola. Even if I'm way up here on my parabola, this yellow point, the distance to the focus and the distance to the directrix are the same. So normally we just think of a parabola as being a U shape, but this is how it's actually formed. Okay, our parabola is all of these points that are the same distance to our focus as they are to our directrix. Back to my paper here. So going off of our equation again, looking back at our equation, we have thought of our equations as being y equals some number times x squared. Here is a new form though. Y equals 1 over 4p times x squared, where p is the focal length. And focal length means the distance from the focus to the directrix, or the focus to the vertex. So here's my parabola, the vertex is right here. This distance from the focus to the vertex is the focal length. Okay. So in both of these equations, a and 1 over 4p, these tell you the same numbers. Whatever number is in front of the x squared is really what 1 over 4p is. So based on our equation, we could figure out where a focus and a directrix would have to be. All of the parabolas that we've seen in our past, I guess, have been vertical. Okay? All of the parabolas we've seen have been functions. They're straight up and down. This chapter, we are also going to learn about our sideways parabolas. They have that same U shape, but just on their side. Okay, and these are very closely related to our vertical parabolas too. The only difference is where our vertical parabolas are in the form y equals ax squared. Switch those variables around. These sideways parabolas are in the form x equals some number times y squared. Or if we look at our other form here, x equals 1 over 4p times y squared. Okay, so if the x comes first, we have a sideways parabola. If the y comes first, we have a vertical parabola. But the same idea, even these sideways parabolas, we have a focus, we have a directrix, and P is that focal length. And again, A and 1 over 4P are really referring to the same number. So that's, I guess, parabolas in a nutshell. Next video, we'll start looking at some examples.